Hello YouTubers and welcome back. It's been a long time since my last video. It's been several months I believe. But the reason behind that is because I made a portable power supply using this Black & Decker toolbox here, which I'm going to show you again shortly. I've made a few alterations to it. It was never designed when first built to be how it was when I built it on and showed you on the last video. I wanted to make a few changes to it. I needed to see whether it actually gave me and delivered what I wanted and what I expected from this portable power supply. So before doing any of the proper wiring and the fuses, which is quite important, you should do anyway, I kind of just did a bit of a basic job on it. I've been using it for the last few months, using it in conjunction with my solar panels, and I have to say it's worked really well. With that in mind, I decided to go ahead and start finishing it off. So what I'm going to do now is to show you what I've done. If you've not seen the other video, hopefully if you click up there somewhere you should be able to click and have a look at that previous video. If not, go and have a search through my other videos I've done. Have a quick look at that one and then come back to this. Okay, so let's have a look at this now. Okay, so this is the box. If you remember, Black & Decker, one of the cheapest boxes I could find, but I knew it was going to do the job. So opening it up, and not much has changed in here from the last video other than we've now got this 240 volt outlet. So if you remember, we had the solar charger control device thing here. That's where you plug in the charger. That's the main switch that powers the main battery to the whole of the circuitry. Voltage, we've got a 5 volt 1 amp and 2.1 amp outlet there, and a 12 volt socket there. This main switch here is the main 240 volt inverter that I'm going to show you shortly inside the unit. Now, one of the problems I found was that I wanted to have everything powered from here to come through the charger controller. The reason behind that was that I wanted to be able to protect the batteries more. In the past, using lead acid batteries, I found that I've flattened them down below 9 volts. Not intentionally, but accidents happen, things get left switched on, you leave things on overnight, whatever, and you can actually ruin the batteries. I'm using 2 lead acid batteries in here. I think they're about 20 amp hour each. Quite expensive, and I didn't want to ruin them. So what I thought was, if I have everything powered through here, I could switch everything on and off via this controller. This would then protect the batteries, because when this gets below a certain voltage, somewhere probably around 11 volts I believe, then it will just switch the batteries off, and that's what I wanted to do. Unfortunately, what I found was when having things plugged in, like portable radios or what have you, plugged into these sockets, and indeed these sockets here, I found that when you come to transmit, you'd get a sudden power surge. This would then suddenly quickly be told it's fallen below the auto cut-off point, and then it would switch this off. So you wouldn't be able to use radio equipment where you have to quickly transmit on this system unless the battery was completely fully charged, and even then it wouldn't last very long until it started to drop. So for that reason, I found that by going straight to the batteries inside, the radios would perform a lot better. Then comes the point of, well, I needed to have a switch here to isolate the batteries from this controller, because if this controller is permanently connected to the battery, then I'm going to be running the battery down even when it's not being used and it's in storage. So what I've done, as it was before, turning that on will power up this controller. But regardless of whether this controller is on or off, all these devices here, these outlets here, and this 12 volt socket, these are permanently connected to the battery, even this inverter. So to turn the power inverter on, flick that switch, and then this is live 240 volts. The downside is that this 5 volt output here would then also be live permanently, and the circuitry in there would again potentially flatten down the battery. So the only thing connected to this switch is this device here to charge the battery, and this outlet here. So switching that on turns that on, shows me the voltage, and it now enables this controller to charge up the battery if I plug in this. Now this is the solar power, the solar panels. It's outside, I'll show you that shortly. By plugging that in there, giving it a second, that green light then comes on. I'm not sure if you can see that or not, but that green light is now on. So I can basically operate all of this pretty safely without flattening down the battery when it's not being used, just by turning that off. If I want to use the 5-volt outlet, no problem at all. I'll plug it in, turn it on, plug what I want in. Yeah, I'm using a bit of power, but you're going to have to remember, don't keep things plugged in permanently in there when you're not going to be using this. I need to switch it off. But these outlets here, this 12 volt and this DC to AC inverter, permanently connected to the battery, so I can operate that independently. This inverter, this will automatically switch off when the battery gets below a certain voltage, so I'm not going to damage the cells there if I was to leave this inverter on. Potentially, if I leave things plugged into these power poles or this 12 volt socket here, yeah, potentially I could run the battery down, but it's one of those things you're just going to have to watch it and just be careful, I guess. So that's where I'm up to with that. Okay, so we'll have a quick look inside now and I'll show what I've done in there. Like I said, the wiring before wasn't adequate. It was more of a temporary job just to get a feel for how it worked and to see whether I was happy with the way it operated. So I've upgraded some of the wiring. This tray here still isn't fastened in properly. I've not found a proper way yet, and I don't think I need anything other than just resting it on the rim. But if we look inside, this is what I've done. Now, I'll show you the base where the batteries are first. These are the two lead acid batteries I'm using. 12 volt, 20 amp hour, wide in parallel. I've used this quite largish cable. I think this is probably 10 mil, or was it 6 mil? Between 6 and 10 mil, this cable. This is actually from a set of jumper leads from an old car jump starter kit. So I've connected these batteries in parallel using the larger cable, and then for the moment I'm just using connector blocks. So the connector blocks then, this is going to be fused incidentally. I've got somewhere, where have I put that? Ah, here we go. There we go. Got one of these off eBay. It's kind of like a little fuse box. If I can take that off, there we go. You can put all your spade fuses into there. This is going to be fastened in here probably over the next couple of days. Going to get a proper junction box here for this as well, and everything's going to be going through, so it's going to be properly fused. Again, because I've updated all of this and I've wanted to go a bit fancier, I thought rather than putting the fuse in straight away, let's just get it working a bit. So in fact, let's just change the angle a bit. So inside here I've got the DC to AC inverter. This is 12 volts. I think it takes up to 30 amps, or it can use up to 30 amps, and and it's rated at 300 watts. So it gives me 300 watts to this socket here. It did come with a fan, a 12 volt cooling fan. Probably not quite as important the way this is set up, because it's not in a very small enclosed box, but I've mounted the fan on top of a battery which just blows across some of the circuitry and the heatsink there. Looking up to the top here, again you can see it is just a bit of a bodged kind of temporary job with the wiring for the switch. This is allowed to be a very thin small cable. This is just purely the switch that controls the circuitry. The main power is permanently connected to the batteries, and then those are the outputs there, the 12 volts and the 5 volts, 1 and 2.1 amps, and that's my switch. So I rewired this and added this inverter probably about 2 or 3 days ago, and I've been using it, and I have to say it's been working really well. It's absolutely perfect for taking out the drone. I haven't got a drone myself. I did have, but it died. That's a long story. But a friend of mine still got one, so we take it out and about. This is perfect for it because we can charge up the control using the USB outlets, and if we need to charge up the battery, he's only got a 240 volt house charger at the moment, so we can plug that into there. So this has actually been really, really useful. Once it's been tested for a little bit further, spent a bit more time using it, again this wiring will be tightened up, smartened up, and it will be correctly fused. It's not the sort of thing that's switched on and left to its own devices. I don't use anything really that requires a lot of current. So with regards to the safety aspects and the potential, you know, problem for fires and stuff, the cable and the wiring that I've used at the moment without fuses is safe, providing I'm just with it and I'm monitoring it. Clearly you're supposed to be using fuses, and I will be having all fuses very, very soon, because I know a lot of people are going to mention that. But putting that aside, it's worked really, really well. If I wanted to plug something or wire something in to the charger controller here to enable me to have a powered and controlled output, then I can do very, very easily, just wire it straight in. At the moment it's been tested and used a lot. I'm down to 11.7 volts. Unfortunately, the solar panels that are outside, it's a 100-watt panel, but it's a very cloudy, overcast day today, so it's not really making much difference. I do have a mains charger that I can use, which I plug straight into the power poles here, and that goes, as you know, straight to the battery, so I can charge this other than solar, so that's not so much of a problem. But like I say, it's been really useful and it's worked well. That can stay on charge. Keep some accessories in there. Don't know where they are now. Those are my spare leads, which I think I've shown you before. It's just worked really well. It's just been it's just been absolutely fantastic to use. I don't know on the sort of time scales I'm going to get if I plug things into the mains, how long that's going to last me for. If it's for portable lighting, to be honest with you, with LED lights nowadays and the cost of those and the efficiency of LEDs, there's no point in having portable lighting that's 240 volts. You're better off having 12 volts or in fact 5 volt LEDs. But mainly for charging things up, absolutely ideal. And like I say, for radio equipment, which you've seen before, this will charge up your handheld radios, and then plugging the main radios portable into these powers nicely. Okay, so I hope that's been of some use to you. There's a lot of people doing these at the moment, these portable power supplies, and you know, just go onto YouTube and you'll see quite a few different attempts, and you get a lot of ideas. And that's the best way to start, to be honest with you. Everyone has got different needs and different requirements. This one suits me, it gives me what I need, and like I say, it's worked really well so far. So maybe I'll add a few more outlets on here. In fact, let me show you this. This is something that I've been working on. Basically, this device here, it's just a junction box with some spare power poles and some banana outlets and a little 12 volt cigar lighter adapter there. That wired into there. I did think about potentially fastening that into here at some point or somewhere, just to give me more outlets. Probably a bit of an overkill, but this is something left over from a previous project. I did think maybe it'd be nice to use this. You can never have too many outlets, can you, at the end of the day? Anyway, that's it. Hope you've enjoyed the video. Give it a thumbs up if you have, and I'll give you an update hopefully shortly with some future developments onto this.